Hi everyone, today we are going to continue our lectures related to finding component of a force with respect to any arbitrary axes which are more likely are not perpendicular to each other, and addition of several forces. Okay, so sometimes there will be a case where we have to find components of a force with respect to two axes that are not perpendicular to each other. For example, let's consider a case where a container in here is held by a beam right there, okay, and then the force exerted by the beam to the to hold the weight of the container is going up, since the weight of the container is going down, right? So in here there's also a cables, okay, which is connecting the container to the beam over here, right? And if you would like to find the component of these forces with respect to axis u and v in here, which are passing through the axis of the cable, we can use the parallelogram law or triangle rule to calculate those components. For example, if I can resketch these forces again, okay, so for example, if I have my force F is sketching right here, right, and then I have my axis U, right, and then I have my axis V, and notice that U and V, they are not perpendicular to each other, okay. So we can find the component of the force F with respect to U and V by constructing the parallelogram itself in here. So we know that in here we can sketch a line that is parallel to V, right? We can sketch a line that is parallel to V, okay, and a line that is parallel to U. Right? So basically, this component right here we can call it Fu, which is the component of force F with respect to the U axis, and we can call this component right here as Fv, which is the component of a force F with respect to the V axis. Alright, in a similar manner, we can use the triangle rule to perform this, to find the component of this force. For example, if I have my force F right there, right, and I know that my U axis is here, right, then, and I know my V axis is right there, right, so I sketch my V axis right there, so I can construct my Fu and Fv, right, by connecting the tail of F to this intersecting point right there, and then I can construct my Fv by connecting a point, by connecting the intersecting point over here to the head of force F over there, okay. Alright, and of course, in order to find these components, you will need to still apply the trigonometry law, right? The trigonometry laws, right? Such as the Pythagoras, right? Pythagoras theorem, or you have to find use the sines or cosines law, okay. And the next topic that I would like to discuss in here is, what if you have more than two forces or more than two factors? How can you calculate the factor summations of those factors, or the factor difference of those factors? For example, in here I would like to, I have factors F1, right, F2 and F3, right, and I would like to calculate FR as F1 plus F2 plus F3, right? So what can you do? Okay, so the first things in here, we have to take the calculation step by step. So we have to first solve for F1 plus F2, and then afterwards we can continue with F3. For example, if I can call this F1, F2, if is F12, right, then FR is equals to F12 plus F3. Alright, and if in this case, what is F12? So if we can label F12 in here, so F12 is equal to F1 plus F2, which is basically the factors right there, right? And then FR, you can find FR by adding F12 with F3 over here, and then after that you get the final factors in here, which is FR right there. Alright, and of course you can do this differently. You can first try to find FR. For example, if you would like to find FR is equal to F1 plus F2 plus F3, if you choose to calculate F2 plus F3 first, that's fine. You will still get the same answer. In a similar manner, if you would like to choose to calculate FR as F1 plus F2 plus F3, if you would like to calculate F1 plus F3 first, that's fine. You will obtain F13 plus F2. Okay, so this all will lead to the same answer, and the key in here is to take the summations one by one. Okay.